Hello and welcome back to the Oxford Online Maths Club. My name's James and today I'm joined by Jack.
Hello, hello.
And also some of you watching live at home around the world and maybe joining in with the Slido as well. We have this live chat thing where you can join in underneath. So it's me in the top right, then Jack, and then underneath maybe you. You can put your name in the Slido. But one of the reasons we're using Slido instead of YouTube chat, sorry, I think somebody asked and I forgot to say, one of the reasons we're using Slido instead of YouTube chat is that you can be anonymous in there if you like. You don't have to have a Google account or something like that. Right, I think I'm live. I think I've remembered to unmute myself. And Jack, Jack, just a quick introduction. You're a current student at Oxford. What are you studying?
Yeah,
Where are you studying?
I'm a first year. I'm taking maths. Enjoying my second term here at Oxford. It's been a great time so far.
Right, one term down, back after
Yeah,
the Christmas break, ready for more maths.
yeah. Got a whole 7 weeks to look forward to. So
Yeah, we do
be
short
good.
terms. We do short terms. So you did. Last time was 8 weeks. Now here we are. It's week one of another 8 week
Yeah,
term. Cool. What was your favourite thing last term, and what are you looking forward to this term?
I really enjoyed geometry last term actually. I really liked shapes. I think it was really cool. And this term, I'm looking forward to multivariable calculus, which is also kind of about shapes, but we do a lot of changing things this time, and they're weird volumes, that kind of thing.
Courses about shapes. People watching at
Yeah,
home will be unsure whether to take you literally there or whether
I'm very little. I enjoy shapes.
It's really an Oxford course about shapes. Hi to Joe
Oh,
and
yeah,
an anonymous
superb.
person. Here they are in chat. And I should also say thank you to Callie, who is another current student moderating chat for us so that chat messages can appear without me clicking on anything. I've got some admin at the start. I want to point at stuff. Maybe you found us today through the Maths Club website. If you haven't seen the Maths Club website, there is a link. Well, there's a website on screen somewhere down there, and there's a link in the YouTube description. The website is maybe where you can get onto chat. There's a link for that too, of course. It's where you can find previous episodes. There are over 90 previous episodes of other topics, some of them with other students. And it's also where I post further reading notes. So after an episode, like last week, we did some puzzles together. After last week, I posted this further reading notes, which is kind of like a blog post with things I forgot to say, things I didn't say very well last week, and also other puzzles and other resources. So I threw in this kind of prime number question and a link to a question about invariance, if you liked that from last week. So I'm going to do that again this week, posting kind of further reading notes on the Maths Club website, which you can get over there. Hi in chat to Ted and Hamish, who have joined in as well. And I see Callie is in chat. Also, Callie has the power to reply to people in chat. We can't see them on screen, but Callie is there too. Right, okay. Also an ad. So we have a summer school called Promise Europe. We run quite a few we run quite a few sorts of summer school. One of them is Promise Europe. This one is notable for being 6 weeks long and containing loads and loads of maths. It's really challenging. They're looking for ambitious people from across Europe, defined quite generally. Yes, it's open to people from the UK before anybody asks, and also lots of other countries not traditionally considered part of Europe, but whatever. They're looking for people aged 16 plus, pre-university, who want to do 6 weeks of challenging maths together. And I figured that if you're watching Oxford Online Maths Club, then maybe that's you. Maybe you're keen on that. Even if you're not in Europe, they have an interesting set of problems, which I think were we talking? Is this the problems we were talking about before, Jack? That they have some.
Yes, I applied last year. The problems were actually really interesting, for sure. Uh, I've seen a couple of them come up again in the Oxford, like the current problem sheets, to be honest.
Right, yeah. So
But yeah, no,
the problems
it's
are hard.
yeah. But even if you don't get in, it's a really interesting thing to apply for. The questions are really good. Yeah.
Joe is working through them. I don't know how many people. Oh, how many people usually apply? I don't know if they publish this, but I think it's about 100 maybe, and they take about 20 people. But I sort of think probably more than 100 people have a go at some of the problems. So, which I think is the important part really. If you're looking at this sort of thing, obviously going on the program is great fun, and you get to come and do lots of maths. It's hosted in in the Oxford Maths Institute. And I've remembered, in fact, I said if you're not in Europe, I've remembered that this is Promise Europe. There is also Promise Boston, if you're near Boston. There's Promise India, and I think there might be a fourth one. I've forgotten where it is, but if you would like to do this outside of Europe, the original one is in Boston, and there are a couple more. Rex in chat has watched the new. Are you aware? Have you heard of this? There's a new TV show on Apple TV. It's called.
I don't think I've heard of it. No.
It's called Prime Target. The concept is that the main character solves prime numbers. He finds patterns in the prime numbers, which allows him to break all internet security, and this makes him wanted by the government, who then track him down in a sort of implausible thriller sort of sequence. The show is on Apple TV, who are, to be clear, not sponsoring this. I just like the title. It's called Prime Target, which seems perfect to me. The problems are the problems are something they use to decide who goes on Promise. Problems are hard. I guess you could call it an admissions test. I think they call it a problem sheet or something. The actual event as well includes loads of problem sheets. It's very collaborative on the event. People work together and explore and try to discover maths. Hi Will in chat, and hi Aaron, who's working through them and says they are hard and interesting. Question 2 has taken more than an hour. Okay. Imagine that. Yes. Hard questions. Questions on proof year 13, says Anonymous. What have we got? We've got an element of proof today, haven't we?
We do. We've got some exciting ones coming up, if we get enough time, at least. It will be quite different to the ones you normally do at year 13, though.
Yeah.
But it's still interesting.
Possibly helpful. We don't normally help with A-level directly. We think that the Maths Club is kind of like an after-school club where you do extra stuff. And I've remembered that I should do my poll. But proof is one of those things that you learn by seeing more examples of true things. I think that's part of it.
Yeah, absolutely.
Jack, I should have said at the start, we always do this poll of how's your day going on a scale from 1 to 5 stars. How's your day going, Jack?
It's got to be a 5 today. Every day where you get to do maths, it's a 5 day.
Is there something specific today, or is it a sort of
I get to be on the online maths club. That doesn't happen every day, does it?
Hakuna Matata. There we go.
And how's your day going, James?
Oh, thanks for asking. I think I'm having a 4-star day. I have had back-to-back meetings. I don't love meetings. I would rather have back-to-back maths, but that's just part of the joy of being a student, is that you can have back-to-back maths all day.
Yeah. 3 lectures of maths in the morning, then a bit of maths when we got back, and now I'm on the online maths club.
See, I think that sounds like the dream. Right, cool. People are voting in chat. They are having a 4.5-star day on average, which sounds like
that's pretty high.
That might be better than the star review on Prime Target, but good to know. I'm always watching out for people who are having a terrible day. It's none of them yet, but I sort of feel a bit for the people who are having a terrible day, and I thought, you know what, I'll log into the Oxford Online Maths Club, do some maths. Lily in chat says, hi, Jack, and good luck. So I don't know if that's someone you know saying good luck.
It is.
I'm gonna hand over to you for your content in a second. I want to set the scene.
Yeah.
You're going to tell us a story about a theorem from a TV show.
I am.
Not Prime Target, which, as far as I know, doesn't contain any real maths. But a theorem from a TV show, which we're going to try and state and explain, and maybe we're going to prove it. Thematically, it's about body swap, right? Do you want to set the scene for us?
So let's imagine 2 people. So this is body 1, and in their head is the corresponding mind 1, because you want their mind to match the body, right? And here's person 2, who also has mind 2. So they match up quite nicely. But someone's invented a machine, and it swaps people's minds, but not their body. So if we use it on person 1 and person 2, it's swapped mind 1 to be in mind 2's, to be in body 2, sorry. And it's swapped mind 2 to be in body 1. And they don't match anymore. Now, we could just swap them back, right? Then everyone's back in the right body, everyone's happy. But there's a slight error with this machine. It doesn't work on bodies that have already been swapped. We've already swapped bodies 1 and 2, so we can't swap those minds again. and they're stuck in the wrong body. The question is, are there times that we can get everyone back in the right body? If there's not, can we do it with extra people who haven't made any swaps yet? And just generally, how can we get everyone back in the bodies that they want to be in?
Yeah, love it. So this machine that swaps minds but not bodies. I love putting it like that. The machine that swaps minds and bodies is like the machine that changes places. People change places. The machine that swaps minds but not bodies is the one that does kind of body swap stuff. You might have met this concept before in the movie Freaky Friday. We were having a chat before about the cultural significance of the movie Freaky Friday. I am too scared to do a poll for chat about whether they've seen Freaky Friday. Possibly the one that I've seen. So Freaky Friday is this movie that Disney keep making. I think it's adorable that they keep making it. They made the movie in 1976, they made it in 1995, they made it in 2003, which is the version that I think of as the canonical Freaky Friday. They made another Freaky Friday in 2018, and if you haven't seen this movie and don't know what I'm talking about, don't worry, there's another one coming in 2025. So you might get to see a Freaky Friday yet. The concept for all of these movies is that a mother and daughter have an encounter with, let's say, this machine where their minds are swapped, and the comedy comes from minds being in each other's bodies. The thing I like is that the poster, it's kind of impossible to illustrate this idea that their minds have been swapped. They're in each other's bodies, but they have a go anyway. My word. I don't know if anyone in chat has come across this, but who knows? They seem to be making them faster and faster. So we're approaching a kind of singularity where at some accumulation point, which we could possibly predict with some sort of geometric series, at some accumulation point, every Friday will be a Freaky Friday. They'll be making this movie every week, possibly with the help of AI. Anyway, that's me, going on about, yes, an anonymous person in chat has seen the 2003 version. Yes.
During the setup, I thought we were going to be the 2025 Freaky Friday with our body swap.
Oh right, shall I? I should have set it up to switch the camera feeds, and then we. Yeah,
you could have done actually. That could have worked.
That would have been a great joke that we've only just thought of now. Okay, so you've got this. You've got the machine that switches minds, but your one's got a defect that.
Yes.
Tell me again.
Yeah,
so
with our machine, you can only swap bodies once. Whatever mind in it doesn't matter at all. You can have any minds you like, but you can only use it on the same two bodies one time.
Right, so that would be bad news for Lindsay Lohan and Jamie Lee Curtis in the 2003 version. If they've had this swap happen, then they can't just swap back using the machine again. Same two bodies can do the swap. And
they're just stuck in the wrong ones, which obviously no one's happy about. Everyone wants to be back in their own body with the correct mind.
Good summary of the movie. Yes, nobody's happy. So the solution, which I suppose the solution is not in the movie because the movie doesn't have this restriction.
No.
But the solution to that kind of conundrum, if you have two people, minds have swapped and you're not allowed to put them back in the machine. Do you want to talk us through the solution of how you might sort that out?
Yeah, well, first, could we think about it just with an extra third person and see, could we work out a solution with that? So our setup is that we've got body one there. Sorry, this is going to be mind one. So I'll draw a circle for the mind. It's like a head, and a big rectangle for the body, because unfortunately I didn't take art. But so here's mind one, mind two, and we'll have mind X just to show that it's very different to the other two. And our setup here is that body two and body one have already swapped, so they're in the wrong bodies, and X, nothing's happened with X. It's just there. And we want to say, is there a way to get body one and two back in the right place, maybe by doing something involving body X?
I see. Okay. So these are like your stick figure characters, right? I'm going to draw arms and legs on them.
Yeah,
you don't have to draw arms and legs. I'm just going to decorate them. Yeah, there we go. Oh, we've both. Okay, I'll decorate doing what. So, question maybe for chat is: people wanted to have been in the mind swapping machine. Oh dear! These two bodies are not allowed to go back in, which would resolve it. But we've got person X over here.
And can we do something with person X to get body 2 matching with mind 2 again, and body 1 matching with mind 1? And remember, we can't just swap bodies 1 and 2 because we've got that defect in our machine.
Right, so Aaron in chat has had, they've been trying something on paper and they've tried adding 3 extra people and they've done quite a complicated series of swaps, which I'm going to read, but I'm also going to read out Hamish's comment. Hamish says swap 1 and X and then 2 and X.
So let's try out Hamish's comment. We've got swap 1 and X first. That's fine. We haven't done that yet. Then we'll have X down there and 1. So X is in 2's body now, and 1 is in X's body. And then we swap 2 and X. So X ends up in 1's body, 2 gets in 2's body, and 1's still in X's body. We've got 2 in the right place, which is better than we started off with. But X and 1 are still in the wrong bodies, and we can't swap them again because we already did that.
2 comments. One, Jack in chat, who's I think distinct from Jack on stream, but possibly
I would presume so.
Possibly with some sort of swapping mechanism happening, has suggested essentially the opposite sequence. But separately, also, I've realised I'm going to get confused. The movie's confusing, I guess. The swapping machine is confusing. When you're talking about swapping 1 with X. Really stupid question, sorry. Are you talking about the minds or talking about the bodies?
Sorry. So
I don't know what chat's talking about.
We'll always talk about the bodies swapping. So I'll keep the minds at the top. You can imagine this as being like columns showing what body's in it at which stage.
Okay.
My pens appear to stop working. But
don't worry, coming.
If you imagine, so that mind at the top always stays constant, and then each row below shows what we had before. So the bodies we had before, and then what everyone's in at the next swap.
Oh, I see. So you've interpreted in chat. I'm not sure we set up the notation for chat, but you've interpreted swap 1 and X to mean
maybe
bodies 1 and X. No, it's fine. We've got both options in chat now. Swap bodies 1 and X, and then swap bodies. So here we've got 2 and X. Swap bodies 2 and X. So that's the swaps that you've done on screen. And that's got us back to, well, body X is now over here, body 2 is in the right place, and body 1 is over here. But we're kind of not quite happy with this solution because, because minds 1 and X have not got sorted out.
Yeah, we'd like to have 1 and X back in their right bodies as well, but we've already swapped 1 and X in the first step we made, ignoring our setup. So we can't do it again. And everyone's stuck in the wrong body still.
I've realised that the other comment in chat, which is Jack's comment in chat, suggests that we swap 2 with X and then 1 with X. But that's just the same. Is that just the same, but with 1 and 2 the other way round?
Yeah. Our situation. The maths term for it would be symmetric. The idea is that we could doing it with 2 instead of 1. If we replace 2 everywhere with 1, we still have the same thing going on, and it wouldn't work again.
Yeah, we're not allowed to put bodies 2 and 1 in the swapper machine. That's the kind of starting problem.
Yeah. I mean, we can write it down with trying with starting off 2 and X as well.
Should we give that a go? Can we erase?
Let's give it a go.
Let's erase. Keep the bodies.
We could start a whole new diagram beneath if you want.
I'm going to erase. I think do it here. I'm going to erase the arrows and the results of the swapping.
Yeah.
So the second suggestion, I can't see another suggestion has come in, but the second suggestion was swap 2 and X, and then 1 and X afterwards.
Yeah. So we'll swap 2 and X first. X ends up in 1's body, and 2 ends up in X's body.
Yeah.
And then was it 1 and X afterwards?
Yes, it's a 2X.
So then we've got 1 back in 1's body. That's good. We've got X in 2's body.
Annoying. Okay.
And we've got 2 still in X's body. Not everyone's in the right body, and we still can't swap 2 and X.
Because we already did that. We already did the swap of those bodies before. Right, annoying. Hamish was using the opposite notation, but I think we've now tried. I think this is all the possibilities, right? I'm becoming convinced that this is impossible.
Yeah, I mean, there's only swapping 2 and X and 1 and X are the only 2 moves that we can make, since 1 and 2 can't swap. We've tried both sequences of them, and neither of them worked. So it must be that it's impossible to do it with just 1 extra person.
Right. Okay. So there's a kind of 1 extra person. There's a clue there. 1 extra person has come in, and I think I'm now convinced, at least, none of the combinations of swaps. You run out of options as you go through. None of the combinations of swaps get you to the desired outcome. For the person who wanted proof techniques, that is called proof by exhaustion. And not just that we got tired at the end, but like we checked all the cases. If you've ever done a big case check where you went through all the possibilities, that's kind of what's going on here. Right.
Yeah, we found that it's impossible to do it with just this 1 person.
Yeah, and on that theme, Tim and I saw Aaron earlier in chat have got solutions where you bring in even more people. So if you have maybe not just X, but also someone else.
Yeah, should we add a 4th person then? If we add Y, just again to distinguish them from.
I'm going to erase the swaps underneath. So there's a lesson here, right? If I notice that Jamie Lee Curtis and Lindsay Lohan have swapped bodies and they can't get back in the swapper machine, then I can't solve that problem for them on my own. I can't just come in and swap bodies with Lindsay Lohan and then subsequently do a different swap. Neither of the combinations work. There's a lesson. You can't solve it on your own. Yeah, you need a friend.
Yeah, for sure. So should we try out Tim's solution, I think?
Yes. Can you see Tim's solution, or do you want me to read it out?
I think I can just about see it. Is it 1 and 2 first?
Yes. There are 4 people, I think 1 and 2, and then they've called the new people 3 and 4, but they're swapping. Wait.
Remember, we can't do 1 and 2 first, though, because that's already in our setup.
Maybe they did edit it. I sort of wonder whether. Right, also because they want to swap 3 and 4, and I really don't want to swap. I don't want to swap 3 and 4 unless I have to, because they're currently fresh people, haven't yet been through any swappy stuff, and feels like I'm making life harder. So maybe Tim's maybe counting the people in a different order. Tim started with no swaps yet. Is the update?
Okay.
So starting with swapping 3 and 4 seems bold. Oh, maybe they're going to end up the wrong way round. Maybe this is fine.
You could give it a try and see if it works.
Yeah, I shouldn't knock it till I try it. You're right.
Yeah. So we use 3 and 4 first.
You get 2 fresh people in and immediately say, right, in the machine you go. Like, what have they done to you? I find that surprising, is what I'm saying.
But anyway, we'll swap X and Y. That's Tim's 3 and 4, I think. And we still have 2 and 1 in their respective bodies.
Yeah, they're just watching that happen. They don't know what's going on.
Yeah, maybe it'll be useful for them later on, though. And then is it 1 and 3 next?
1 and 3.
Yeah.
Yeah.
And do you think he was referring to the body?
Numbers referring to bodies. Yep.
Yeah. So then
3.
that would be swapping
1 and X for us
into 2's mind and 1 into Y's mind.
There are quite a few more swaps to come. Because next, after 1 and 3 for Tim, it's 2 and 4, which in our notation is 2 and Y.
Yeah. So that's. What, isn't 2 and 4 what we just did?
No, we just did 1 and 3.
Oh, yeah.
And now it's 2 and 4, I think. Then it's going to be 1 and 4, and then 2 and 3. Joe has got a shorter sequence if this doesn't work. And Aaron is agreeing with Tim at the moment.
Okay.
Sorry, so we've just done 1 and 3. Next up it's 2 and 4. So for us that's 2 and Y. So I think.
Yeah, sorry. So which is Y goes over here and 2
over there. Yeah, cool.
Yeah.
X and 1 stay still. And then 1 and 4. So for us that's 1 and Y. which is exciting. He's going to fix person 1 and person Y. Oh yes, look, and these
That's
two people are
good,
the wrong way around as well.
but we haven't used them yet, so
We haven't
we
swapped
can fix them on the next step.
We haven't sent exactly that combination. The machine remembers combinations of people, not individual people. The machine is sort of under a weird curse. It won't accept the same the same pair of bodies for the body swap. I guess in terms of a maths puzzle, that would make it too easy because you would be able to just undo the swaps that you'd already done. And whereas here, yeah, that looks like it's got us back.
I think I'm pretty happy with that one.
We've done a 1x, we've done a 1y, we've done a 2x, 1, 2, 3, 4, and the original one. We've done, if you count the first original Freaky Friday situation, we've done 5 swaps total.
Yeah.
Oh, 6. Did I skip one? I didn't count this one because I didn't draw the pink arrows.
Always good to
6.
draw the pink arrows.
Welcome to the Oxford Online Maths Club. Counting is not my strong point. There are 6 swaps total, which is in fact all of the possible switches. We've gone on a kind of grand tour of.
Yeah.
By the end of this, any pair of people have been in the machine together at some point. Cool, I think that works.
Yeah, we found a solution, and there might be a shorter one, but the important bit is we found a solution, and that's what we're mainly looking for here. We don't care too much about how long the solution is, but I'm feeling pretty happy with that solution. I'm feeling good.
Yeah. Well done, Tim, I think. And I'm checking
nice
Joe's solution as well. I'm following it through. I've realised that you can follow through for Tim, they're numbers, right? Or for Joe, they're numbers and letters. For us, they're numbers and letters. You can kind of follow through. If somebody gives the switches, you can follow through what would happen to person 1 or body 1, I suppose. Yeah. Where did it go? You can look at just the ones where it appears. So I've finally worked out a quick way to check them.
That'll work nicely in a little bit later, actually.
Okay, cool. So this is a solution to the Freaky Friday situation, but with 2 extra people. Maybe it's you and me. I quite like it because it did work in the end. I was suspicious at the start, but it says it's sort of the 2 people have got switched. Jack and I arrive and immediately assert dominance by going in the machine, switch minds straight away. That'll mix things up. And because later, through the sequence of switches, everything works out in the right place. I'm trying to work out, if we don't do it that at the start, can we do it at the end? Maybe. Maybe we can do it at the end.
Yeah, there is a solution with us doing it at the end as well. That was the one I've planned, but this one works as well, so I've got no problems with it.
Right, if we don't switch minds at the start, then everything follows through with, well, our minds switched effectively if we don't do that initial switch that Tim's proposing, which then by the end of it means that we'll be the wrong way around, but we can fix that.
But then
in my version, we haven't been in the machine yet, so I think I agree that we'll get in the machine at the end. I do like the flair of doing it at the start. Rebecca's got solution 1, 2. Could you do it with 1, 2, X and Y? So 2 goes to Y. Hang on, I've worked out how to check these quickly now. So I'll demonstrate on Rebecca's solution here, right? So 2 and Y, X and 2, 1 and 2, and Y and 1. The way I check it is I think what happens to each of them. So 2 would go to Y, and then to X, and then and then stop. And Y would go to 2, and then to X. So no, Y would go to Y would go to 2, and then I thought I'd worked out how to check these quickly. I might have been wrong.
No, I think it is a thing that works. So if we remember in our setup, 1 goes to 2, then I think 2 goes to Y in Rebecca's comments.
Oh yeah, okay.
And then is it just Y to 1 that it appears?
There is a Y to 1 at the end. Okay, so they're going back to
1. Okay, cool. 1 goes back to 1. 2 goes to 1 in our setup. Then 1 goes back to 2 in Rebecca's comments.
Okay. Good puzzle. I like it. I like this is the resolution to what happens in how would you solve the movie Freaky Friday with the additional constraint that two bodies that have already swapped can't go back in the swapper machine. The thing from the theorem is bigger than that, right?
Yeah, it's a bit bigger. So it says that we can do it with more than just 2 people. We can do it with any number of people who've been swapped around in any method, with only using two additional helpers, X and Y, who haven't undergone any swaps yet.
So
So
this is great. Hang on, let me think about this. So this is from the TV show Futurama, I think you told me.
yeah, yeah.
Which is
I haven't actually seen Futurama, but
Ah.
I'm told this is what happens in it.
Futurama is by some of the same people who made The Simpsons. It's set in the distant future, and this sort of body swapping, that stuff. Lots of the people who work on the team are maths people.
Yeah.
So it's a surprisingly nerdy TV show. So okay, so during the TV show, there's lots of swapping happens, but then the result is that even with as many people as you like who have done as many convoluted swaps previously in the episode, you're telling me that we still only need X and Y who haven't done, and their thing is that they haven't done any swaps yet. Two new people, X and Y, who can solve everything.
Yeah, that's exactly what I'm saying. I'm saying we could have 100,000 people who've all done weird body swap, like permutations or something, and all we need is two people who haven't swapped with anyone yet, and they can get everyone back in their original bodies. Might take a while with 10,000 people, but yeah, they'd get there eventually.
I think I'd have guessed it would be, as many people as there are who have done swaps. Because at the moment we had two people who did swap, and we needed two more. You say 100,000 people got mixed up during this episode, or whatever. Maybe I would have guessed that you'd need about 100,000 extra fresh people just for storing the minds in. But apparently, no, you're gonna prove, I think.
Well, hopefully, it depends how long it takes.
Let's see. Okay, I'll shut up and let you. Off you go. Let's
so, go. Before we think about any arrangement, let's think about something called a cycle, which is where if we've got minds like one, the pen appears to have stopped working again. If you wouldn't mind drawing just some minds for games, just like
how many are we doing? One?
Say 5. Okay. Why not? So we've got minds 1 through 5, and then I seem to be working again. So,
hello again.
So minds 1 through 5, and they've all been swapped into what we call a cycle of bodies. So number 1 is in body 2, number 2 is in body 3, number 3 is in body 4, number 4 is in body 5, and number 5 is in body 1. And we call this a cycle because it's like 1 gets put in 2, then 2's been put in 3, 3's been put in 4, and so on until we get back to 5, which goes back to 1, and it repeats again.
Right, it loops around. It's really, really not obvious how they got in this situation. Like, what have you been doing with the swapper machine? Like, oh my goodness.
But what we're going to find out is it doesn't matter how they got in this situation. I don't care what swaps they did before. As long as it's like this, I know how to get everyone back.
Wow. Okay. So somehow they've got into this cyclic situation where they're all, I guess, standing in a circle, looking sadly to their left, which is where their correct body is. Sort of Freakier Friday situation. There's more than 2 of them. Okay.
I am going to introduce a little bit of notation just to make things easier to explain, but it's not a lot, so don't worry too much. If I have 2 numbers here, like 1 and 2, and they're in some brackets just like that, that means I'm going to swap 1 and 2. So we're swapping bodies 1 and 2, and I can put anything I like in there. I could put X and 3, then we swap X and 3. Let's put some body X and a body Y at the top again.
That's good for chat as well, because they can type brackets and things. So we'll use, just to say it back again, brackets around thing, meaning you're going to swap those bodies. Again, I'm referring to.
Yeah, and then there we go, X and Y.
Easier than making a little ASCII arrow, which is what we've been doing so far. Put brackets around them. There we go.
And we'll note the order of the numbers doesn't matter in the brackets. We're just swapping the pairs. So writing X3 is exactly the same as writing 3X. It doesn't matter. And also, this one's a little bit more complex and a little bit harder to write in the chat, but we won't need to use it too much, so don't worry about it a lot. If I write out our whole set of people, so 1 through 5, and then X and Y, like that. And then I write out some numbers underneath. So here, what we have above is 2, 3, 4, 5, 1, X and Y. This tells me that 1 goes into 2, 2 goes into 3, 3 goes into 4, 4 goes into 5, 5 goes into 1, X goes into X, and Y goes into Y. So everything is being put into the thing beneath it.
Right.
And this is just our setup. We say body 1 has been put into mind 2, body 2 has been put into mind 3, and so on.
It's the same information as your diagram at the top, but we've now dropped any pretense of drawing stick figures.
Yeah,
the
part
information is now
of mathematics is a little bit of abstraction. So
right. We've now drawn it as right, which is I guess harder to type in chat, but
a little bit. But it's going to work quite nicely for just showing things later on with the proof. Otherwise, it can be very difficult to talk about. And this is pretty standard notation for some things you might come across in later on in maths. You'll see the brackets with 2 numbers in again, and you'll see these full list of numbers on the top with what number they go into at the bottom. You'll see that again as well if you end up doing some higher level maths.
Somebody in chat asked about derangements, because I think we talked about derangements on the show once. It's a permutation, I suppose. In maths, the word permutation includes ones like this, where some of it is mixed up and some of it is not mixed. Like those X and Y people are not currently mixed, and the rest is being stirred around. Permutation is like that. I guess you know that from A-level maths, perhaps, where you can get permutations of the letters of the word Mississippi, and it's okay to spell Mississippi. That counts as one of them. You don't have to mix the stuff if you don't want to. Yeah, I've remembered. People in chat know about permutations. Of course they do.
Great. So yeah, all we're really thinking about is permutations here, and yeah, we'll get back to permutations a bit more later. For now, I'm going to make a claim, and it's a bit of a bold claim, but I'm going to make the claim anyway. I'm going to make the claim that the permutation 1 goes to 5, 2 goes to 1, 3 goes to 2, 4 goes to 3, and 5 goes to 4. And then this one's a bit weird. Just go with it for now. X is going to go into Y, and Y goes into X. My claim is that this permutation is possible only by swapping things involving exactly one of X and Y, and not using any of them twice. So, for instance, some swaps I'm allowed to make. I'm allowed to say something like 3x, just like before. That's fine. It involves one of X and Y. I'm allowed to say 5y. It involves one of X and Y. I'm not allowed to say things like 3, 4. It doesn't involve X and Y. Maybe that happened already to someone.
Right.
So I might not be allowed to use it. So
this is
to be
the
extra
worst
safe,
case, isn't it? The worst case that maybe 3 and 4 have been in the machine. We don't know how they got like this. I haven't got time to work out or engage with which of them have or haven't. So if it doesn't involve X or Y, then it might have already been part of the episode. Okay, might have already happened.
Because we know nothing's happened involving X and Y yet, so we're definitely safe to use them. And I'm not sure if I'm safe to use the other things.
Okay, so you're going to build that permutation. That's not the one that they've got themselves into, is it? Is it?
So this is the kind of the opposite. If they're already in, if 1 is already in 2's body, but I can make this permutation where I put 2 back into 1's body. If I do that, 1 ends up back in their own body. And now at the moment, 2 is in 3's body, but then my new permutation, I say, is going to put 3 into 2.
Right.
So with the setup, everyone's going to get back to their own place.
It's like, except for the X and Y bit, it's like the inverse transformation. You're not claiming that you can recreate it, you're claiming that you can fix it. which is
Yeah.
better.
So I'm not going to be recreating it. I'm going to fix it and get everyone back. And we're not too worried about Y and X because I'm not going to be using a swap of Y and X at any point, which means it's always left over so they can swap at the end.
Oh right, like our grand finale, like we talked about before, that you can swap X
Yeah,
and Y right at
just
the end.
like happened in the first example.
Can you
So
swap them right at the start for like Tim was doing?
we could do just for a cycle, but if we had maybe a few cycles going on, we might want to save that swap for
Okay.
later.
So later on, I should think about it as a grand finale.
Yeah.
Okay. Sorry.
So
I've
it does seem a
again.
bit random to leave it like this at the moment, but it's going to be important for later.
Okay. So your claim is that you can build that thing out of swaps that involve X or Y, but not both, and not neither.
Not both.
Okay.
So it's going to involve exactly one of X and Y, and none of them are going to repeat either. It's just going to be one of each one at most.
Okay. Element of proof. Is it something that you can prove on the stream, or is it something that?
Yeah, no, it's absolutely something I can prove on the screen. That's yeah. There is a slightly more general proof. I'm going to not do the fully general proof and keep it a little bit simpler because that's all we need.
Let's start simple, and then if we've got time, do the harder case.
I mean, it'll give us the exact same result, so it's not even a very interesting more general result. It's just a thing that's true. But so I'm going to say the sequence X swaps with 1. Oh, sorry, I went a little to the left there.
That's right.
Then X swaps with 3. Sorry, with 2. My pen stopped working again. There we go.
Okay.
X swaps with 2. And now we're going to have Y swapping. So Y swaps with 3. Then Y with 4. Then Y with 5. Then X with 3. And Y with 1 is exactly the permutation that we're looking for.
Wow.
It kind of comes out of nowhere for this specific example, but there is an idea going on here.
Okay.
But should we check it works first?
Yeah. Is it possible? Can you increase pen thickness a tiny bit?
Yeah, absolutely.
I've got to. I knew this would happen. I've got to 32%. So sorry, techno. So this is. Is there a pattern here that I should spot, or?
Yeah.
X with 1, X with 2, Y with 3, Y with 4, Y with 5, X with 3, Y with 1.
Yeah. So the key thing here is I'm going to go up to some number in X, and we can call this number I. So I've gone up to 2. I've picked I is going to be 2.
Okay.
Then we start Y with the number that comes afterwards, and we keep on doing that until we get to the last number in our series, which is 5. So we keep on doing that until we get to 5. Then I'm going to do X with I plus 1 again to get that back in the right place. And then Y goes with 1. And I actually could have picked any number I like to be I here, as long as it's less than 5. The proof gets a little more complicated if you do it in terms of I. But so I just picked I equals 2. But there's nothing specific about 2 that makes it work. It would have worked with any number.
Oh, I see. So your proof is going to be something like, the first bit is going to be X swaps with some of the people, Y swaps with the rest of them, and then there's this extra couple of swaps on the end that I don't understand yet, but I'm sure they'll be important. And it could be anything. Is this sort of going to be true for any value of 5? Sorry, or is sort of
yeah. So we could go up to any number if we like. I picked 5 so that we have something to go up to, but I could have picked Y equals K and had some dots in.
You're very kindly doing a specific.
Switch to Y equal K if you like.
No, I think I like having a specific example. I suspect that something works in general. Maybe chat can play along at home as well. I know I said something really stupid there, which was for any value of 5, but hopefully chat can work out. But I mean, if there was a variable there, like n or something, then it would be true for any value of n. And here n is just exactly 5. 5 was like an example.
Yeah, it would absolutely work for any value of n.
But I should let you stick with 5.
So as long as cycle as we like.
Instead of writing n things, you can write 5 things. Got it. Right. Okay.
Yeah.
I interrupted. I think you were about to tell me that this works.
Yeah, so let's ignore the last 2 for the moment.
Okay.
And just one thing with we call this a transposition. one thing that's weird about these is mathematicians can't decide what order to read them in.
Oh.
Some people say start on the left and move towards the right. Some people say start on the right and move towards the left. I'm going to start on the right and move towards the left. So we're reading right to left. Sounds good. Okay. Let's ignore the first two for now. So we're ignoring y1 and x3. And let's just think about where everything else goes. So I've laid out some big brackets here. It's going to look like our permutation up at the top. And we'll just write x3 and y1 next to it so that we don't forget about them later. James, could you tell me where did 1 go?
Oh, right.
Just in
okay. So 1 is not too bad. If we're ignoring these last two, or possibly first two, depending on how you
ignoring
count.
those two.
Ignoring these ones over here. 1 is body 1 only goes in the machine once over here, right? And if that's happening last, then I'm pretty confident that body 1 is going to switch with body X.
Yeah, absolutely.
So what's our notation? Our notation describes where the bodies go. So I guess is there like a 1x in here or something?
Yeah.
So
absolutely.
So there's a swap here. 1's going to end up in x. Okay.
So 1 gets swapped with x, and that's not too bad to see. 1 doesn't appear anywhere else apart from those first 2 brackets, which we're ignoring for now. And then it has to swap with x. That's the only thing left.
Okay.
And then 2 gets a bit more complicated. Remember, we're moving from right to left. So first, 2 switches with x in this bracket here. But then x switches with 1. So 2 goes to x first, and then to 1. So our final result is 2 goes to 1.
Right. Okay. Good. And 3... Oh, I haven't really followed 3, but I guess 3 is only in this swap in the middle, if I'm ignoring those ones. 3 is in this swap in the middle, so 3 is switching with body Y. 3 and Y are switching.
Yeah, absolutely. And then 4, we kind of have the same thing going on as happened with 2. So 4 swaps with Y, and then Y swaps with 3. So we have 4 going to 3.
Okay. And 5, I see, so 5 is involved here, switches with body Y. And then, if everything was fine beforehand, then I'm still talking about this mind or something. So then it switches with body 4 and then stops.
Yeah, 4 doesn't appear anymore.
4 doesn't appear anymore.
Just stop.
Y keeps doing stuff.
Yeah, but 5's not Y anymore.
Yeah.
Now 5 has gone to 4.
Gosh, this is... I can feel my mind leaving my body and going to somebody else's body, perhaps. And so 5 is going to end up in 4. Or 5, the body 5... The mind that was originally in body 5 is now in body 4. Did I get it right?
Yeah.
Okay.
But remember from our setup, the mind that starts off in body 5 for this one is 4's mind. So that's good. We want it back in 4.
Right, okay. You're building
it gets a little confusing to think about the minds and bodies too much here. But
sometimes the abstraction means that I've lost track of which way round we are. Like there's a kind of inherent minor sign in which direction we're going.
Yeah. Yeah, just remember we want everything to go to the body that's 1 less than it at the moment. So apart from 1 wants to go to 5. But we want 2 going to 1, 3 goes to 2, 4 goes to 3, and 5 goes to 4.
Okay. This is a bit like reading people's chat messages, actually. That you can kind of piece together, reading through the chat message, what will happen next with each of them.
Yeah. I
was bad at that as well. Here we are. So 5 goes to Y goes to 4, but then stop because there's no more 4s. So I think 5, the next column of this big switchy matrix thing, it's 5, 4. Rebecca in chat asked, is this a non-linear transformation? I think, linear transformations are the nice ones. This is the sort where anything can happen.
And it's not operating over a nice space as well. It's only going from the numbers 1 to 5 and then X and Y as well. It's a bit of a weird transformation.
Yeah.
And my 5 is also very
we're reading right to left. And I think the tradition reason for that is if you think of these as like operations or functions, like a thing that's being applied to a situation, it feels a bit more like a function maybe. And
these are all technically a kind of function. and functions we traditionally read right to left.
Right.
So
like you have if you have f of g of x, that means do g first and then do f, even though that's reading right to left.
yeah,
So there's this tradition of reading operations right to left, as if they're all applying to the kind of input here is some minds, which is like some sort of like brain that sits over here somewhere, and all of these are kind of functions that are applying. That's what people are thinking of when they're doing right to left. Anyway,
yeah. I mean, some people do like to read these left to right. It depends on who's doing it. So don't be too surprised if you see something like this going left to right. But with these specific functions, people like to go right to left.
Some people do that with functions as well, but yes, never mind. All sorts of notation is available. Thanks for asking, Hamish, because I think it is one of those things that you can never say too many times. Are you going to tell me where x and y go as well after doing?
Yeah, so ignoring those first two brackets again, x doesn't appear until the bracket with 2. And then it says x swaps with 2.
Yep.
And then 2 doesn't appear again, so we must have x has gone to 2.
Right, okay. And ignoring these first two, this one I think is the fun one. Or maybe not, because like body y switches with body 5. I was expecting a whole chain here, but actually body y switches with body 5, and then body 5 doesn't go in the machine again. For all of these.
Yeah, there's not really any long chains going on here at all. We just, everything gets settled pretty quickly.
Oh, that's so weird. So the letter Y appears loads of times in these switches, but for mind Y, you can work out where it ends up really quickly because it's now over in someone else's body, so it doesn't care anymore. Mad. Okay. Good.
So
yes.
If we do the x3 bracket next.
Right. Okay. So you've worked out what happens from a combination of all of these switches that you're proposing from here onwards.
Yeah.
These other two. Okay.
Yeah, and now we've still got those 2 swaps left to make, so we'll put them in as well.
Mm-hmm.
If I write up the 1, 2, 3, 4, 5 x and y up here, and then the y1 because we haven't done that yet either.
Mm-hmm.
We say x switches with 3, and then remember from this big bracket here, 3 goes to y.
Okay.
So x is actually going to go to y here. Does that sound okay?
Yep, that looks right. This looks like vectors and matrices, but I think it's got nothing to do with vectors and matrices. So I'm trying not to use the vectors and matrices part of my brain. Okay.
Yeah, we can rewrite everything in terms of a matrix, but it gets kind of awkward. So we won't worry about it too much.
Okay, let's not use matrices today.
Yeah.
I think the other interesting one is 3, because 3 is involved in this swap.
Yeah.
It says that if you first did the swap body X with body 3, then that would affect the presence for those minds that were going in initially. You'd then have to follow them through this channel. So can I do 3? 3 would go to X and then to 2. So I think 2 here.
So 3 has to go to 2 overall.
Right.
And then
yeah.
Nothing else has changed. So we can just
everything else is the same.
Put in everything else that's the same. Yeah. And it's looking pretty good. We're getting pretty close to what we wanted. We just have, this was 5, I think. We just have 5 and x in the wrong place.
Mm-hmm.
And this last thing, it doesn't look like it, but it's going to fix it for us. Because if we look at where y goes, y swaps with 1, and then 1 goes to x.
So the combined effect of that is mind y, if it started in the right place, would now be in body x. Yeah.
So now we have y going to x, and 1 goes to y, and then y goes to 5 in this big thing here.
Right.
So we must have 1 goes to 5, and then everything else also stays the same. So we have 1, 2, 3, 2, 4, 3, 5, 4, x and y.
Yeah.
And if we look at that and then compare it to what we had at the start, just by doing that sequence of swaps, everyone gets back to their original bodies.
I like this. So there's a bit
apart from x and y, but we don't worry about that. It's okay.
So I guess there's a bit of homework. If people want to check this, because there's a lot of steps there to follow through the swapping. And then you gave a kind of template for how, well, apparently this number I, the point where you switch from x's to y's, x switches to some of them, y switches to some of them. The point where you switch from x's to y's doesn't matter.
Yeah, you can pick anything except the last number. You need to have something else to go to. But as long as you don't pick 5, it'll still work.
Fixing all of that is almost there with just a couple more switches. So there's something for people at home to maybe try generalizing to see, well, you can replace some of it with I and nothing goes wrong. Maybe also worth checking, you can replace 5 with n. You can have lots of people and nothing goes wrong.
Yeah, you can have as many people as you like, and as long as they're in a cycle, our method works so far.
We've got 5 minutes to justify why you're now also done whatever they had, whatever mess they got themselves into. So 5 minutes, Jack. Floor is yours.
I've got a nice diagram for this. So
yeah, let's go.
It's not a full formal proof, but 5 minutes will do for a start. Let's consider a nice big thing, maybe with 9 people, right? So we've got 1, 2, 3, 4, 5, 6, 7, 8, and 9. And I haven't thought about these numbers beforehand at all, but let's pick what bodies they're going to. Say 1 goes to 4, 2 goes to 6, 3 can go to 2, maybe 4 goes to 5, 5 can go to 1, 6 can go to 9 we haven't used, 7 can go to 8, 8 can go to 7. What haven't we used yet? We still got 3 left, so 9 can go to 3.
So this is some really complicated situation involving 9 people. It's not the nice, beautiful cycle that you were just talking about, where they are all glumly looking to the left in a circle.
Yeah. No, there doesn't seem to be anything particularly cyclic about this one at all. But let's pick a number in it. Let's start off with number 1. It's the first one. It's a nice number to go with. And let's look at what happens to number 1. We say 1 goes to 4. So we'll draw a little arrow of 1 going to 4. There we go, 1 goes to 4. And then we say 4 goes to 5.
Could be anything.
And where does 5 go? 5 goes back to 1.
Yeah.
And we found that there was a cycle contained. And well, what about the other things? Where 2 goes to 6, and then 6 goes to 9, 9 goes to 3.
So while you're mapping out the rest of the people, I could be getting people X and Y, and I could get them to fix that cycle using the maths you just showed me. I could get them to fix that cycle first.
Yeah.
And the plan was it wouldn't use both X and Y, but I could fix that cycle just using X and Y. And then I see your next bit of cycle, 2, 6, 9, and 3. And I think, what have they done? And go and fix that one next, because my people X and Y haven't swapped with anyone. So they can play these games with 1, 4, 5, and then they can go play the games with 2, 6, 9, 3. And then is it just 7 and 8?
Yeah. But yeah, exactly. We can work with each cycle independently of the others. And we know that we can always do it with a cycle. So if we just do it with each cycle, we can do it for any permutation of people.
If you map out the problem, then they will be in individual cycles. Each mind has gone somewhere, follow the arrows, it'll loop back eventually and make a little cycle. I like that. So address the cycles one at a time. It's pretty good.
Yeah, absolutely. And I mean, this isn't a full proof that every permutation can be turned into cycles like this. But it could be a fun exercise to think about. It's not an easy proof, but it's not horrible to think about.
Yeah, so if you've got n items that you can distinguish, so n distinguishable items, and you consider some permutation of those, is it always the case that you can identify cycles? Can you map out cycles where within a cycle it's just doing that simple rotation kind of thing for all of the people? Possibly none of these people, obviously it wouldn't be a problem for the switching, but if some of them were in their own body, just leave them.
Yeah, then we can just think of it as a cycle of one person.
A cycle of one person, people, but
we can just ignore it. We're all good.
You discover Lindsay Lohan in Lindsay Lohan's body, and you think, yeah, that checks out. That's all right. That's
Yeah,
how Lindsay Lohan
that's where she's
is.
supposed to be. We're all good.
No cycling needed. No switching with X and Y. Just
Yeah,
leave them
and
alone.
although we had in our cycle thing from earlier, we did have X and Y switch, and we're not necessarily sure how many cycles it'll take. So we don't know whether X and Y are in the right body right at the end after all the cycles. But remember, we haven't switched X and Y at any point. So if necessary, we can just switch them back. We might not need to, but if we do have to, it's fine. We've still got X and Y. We can just switch them.
And you foreshadowed that right at the start with this kind of grand finale. X and Y could maybe at the end they might, worst case scenario, they might switch, but grand finale they can switch. Love it. Yeah, so that'll get them back into the correct places. Good. Okay, I like that. Lots of things for people to think about if they want to think about these permutations or switching people around. It's really cool to me that this was in a TV show. This was in an episode of Futurama. The proof is in the episode on a whiteboard, very briefly, on screen. I'll put a link in the further reading if you want to have a look at the episode and this bit of Futurama. Which, if you've never seen the show, you'll look at it and think, oh, that's The Simpsons, but I don't recognise the characters. Same art style. I think it's a natural point to stop as well. Thank you very much, Jack, for coming on the show. We will put some further reading notes together as a blog post tomorrow on the Maths Club website.
No, thanks for having me. It's been a good time.
Anything else you'd like to point people to? It's kind of related or other stuff that.
If you want to know more about permutations and stuff, it'll come up a lot in something called group theory. We'll find out all these permutations and transpositions and stuff have all been part of a group, and that justifies some of the other stuff we've done as well. But if you're interested, look into group theory. You'll see a lot of it.
Smashing. I might have to put that in the further reading now. So if you want to see more of the show, we're back in 167 hours for another episode of the Oxford Online Maths Club. If you want to see more of me, my name's James. I stream on here on Thursdays, and I stream on Twitch on my own Twitch channel, which is James Monroe Maths. Thanks for asking in chat. James Monroe Maths on Twitch on Sundays. I'm definitely allowed to promote my Twitch channel. Don't tell me I can't. We will see you either way back here Thursday for another episode. Have a nice evening. Have a nice weekend. Take care, everyone, and keep doing maths.
Bye.
Bye.